Thanks everyone for joining this month Data Science on AWS Meetup. I'm very excited today. We have a great line of speakers. Just a couple of announcements. So again, Chris and me, we're hosting this every month. It's also a lot of content is coming from a book we wrote, Data Science on AWS. And a quick announcement here. The book got translated into simplified Chinese and just got published, I think, a few weeks ago. So after Japanese, German, what else do we have? Polish. We do have now also a simplified Chinese version. If anyone is interested, I'll put in the link here in the chat. And we're hosting this monthly meetup here to invite great speakers from the community to talk all things data science, machine learning, data platforms. So for the meetup today, let's switch to this. We do have a packed agenda. Super excited. I'm welcoming Amber and Stefano, who will do the first talk today from Arrikto to talk about managed multi-cloud SaaS-based Kubeflow. We also have Jagane and Jitendra today with us. They're going to talk about managed multi-cloud SaaS-based MLflow. And Joel will join us as well later, talking about building a data mesh architecture with two tool sets that are pretty exciting, datamesh-utils and data.all from AWS. All right. Anything else, Chris? Any other announcements to make?
No, I think we want to just keep a close eye on the time, because I know we have some very chatty folks on here and we want to make sure Joel has time to talk. So yes, Amber's very chatty and I know Jagane's very chatty. Jitendra, we're all chatty people. Yeah, myself included. So.
All right, I'm gonna stop my screen share and hand it over to our first speakers, Amber and Stefano. Take it away.
So I'm loading up the slides. I'm Amber Graner. I'm the VP of Marketing and Community, and I handle all our partners and alliances at Arrikto. But I'm also been around open source since the early 90s and have enjoyed both the software and the hardware side of open source. And Stefano, while I am loading up the slide deck, if you want to introduce yourself, that would be great.
Hey everyone, I'm product manager at Arrikto, mostly working on our MLOps tools and capabilities.
Thank you, Stefano. Also, we have joining us who will be in attendance, just in case Stefano and I can't answer some of your questions. We have Chase Christensen, who's our solutions architect. We have Sohail Nadi, who's our head of field data science at Arrikto. And I believe our SVP Pete Graner will also be joining, just in case, you know, there's questions that we can't answer. So with that, we'll get started. So as soon as I click my screen here. So here's Kubeflow. You know, Kubeflow, for those who may not know, is a project that's dedicated to making deployments of machine learning workflows on Kubernetes, simple, portable, scalable. And the goal of the project is not to recreate other services, but to provide, you know, a pretty straightforward way to deploy best of breed open source systems for machine learning and really diverse and complex infrastructures. So anywhere you're running Kubernetes, you should be able to run Kubeflow, because Kubeflow runs natively on Kubernetes. So a little bit about Kubeflow. There are more than 1,000 contributors. And I only pulled data from about the top 9 repositories a few months ago, and there were almost 170 companies contributing. Now that 1,000 plus is individual contributors, but there's almost over 170 companies that have contributed to Kubeflow since 2017. And if you look at the GitHub stars, I look at stars sometimes as vanity reports, but when you look at the stars and you look at the popularity of it and how it's growing, we see a very diverse, very growing, and very interested community who's very dedicated to making sure that Kubeflow is successful and is a competent, mature project with a community that is trusted and that people have confidence in the community as well. And you might have heard, if you were at KubeCon, Google has now initiated the pull request to have Kubeflow project moved over to the CNCF. So you can see that we're growing. And for those distributions that you see listed here, AWS, Google, Microsoft, us at Arrikto, and others who are building distributions on top of Kubeflow, you can see that we're all very excited to see it moving to a neutral space so we can continue to grow not only the community, but also the maturity of the project as well. And Arrikto is helping lead several of those working groups, as well as taking an active part in the transition to the CNCF. So let's talk about what organizations want. And don't worry about what I'm about to talk about, because there'll be a slide that'll be included in the deck that I'll share with everybody after this. We've seen that, organizations want like a frictionless handoff between personas. So whether you're that data scientist, whether you're a data engineer, whether you're DevOps, SecOps, whether you're part of the MLOps team, you want to be able to share and hand off your models and your work seamlessly between all these different personas. You want easy to write pipelines. You want available and resilient platforms, auditing and acceptance criteria. Everybody has a different opinion about the tools they want to use and how they want to use them. And if they're secure, do they work? Maybe the data engineer wants Kubeflow, but they haven't talked to their data scientist yet. So maybe the data scientist doesn't want that. And so there's all these complications that kind of go into making sure, all of this works. And you want to be able to serve models. You want to be able to train and bake and promote and repeat, all of these things. And so around 4 to 5 years ago, when the hype of machine learning and data science had just started, everyone tried to capitalize on the trend in a rush, right? Like if everybody remembers when that started, everybody's kind of rushing to the table. And then individuals would spend, a lot of amount of time and effort to learn machine learning. And in contrast, companies, think about the companies that was just listed on the other slide, pump millions of dollars, it seemed like overnight, into launching their, machine learning and data science projects. But, according to, maybe you don't know, but according to a 2020 report, a lot of companies failed. And the main reason behind this high failure rate is that everybody focused on learning machine learning and the data science concepts with like a proof of concept work with their local Jupyter notebooks in those initial days. And there was really no thought on the process of how the practical execution in the real world with machine learning projects were, and to deliver them in production successfully. So this kind of lack of understanding in the early days became visible when various projects actually started to fail in these companies. So that's where, when you think about it, that's where this next slide comes. That's the one I'll share with you what I was just talking about. But when you think about it, how many of you all, when you think about the different personas, the data scientist, the data engineer, the ML engineer, the DevOps, the security ops person, when you look at all those personas and you look at what they're doing to build their models, and not only what they're doing, but all the different applications and tools and platforms that sort of go into every piece of this. And people are these personas are, stringing things together and putting them together and using them. And sometimes it takes months to get it right. It takes months to get that flow right and to, get everything trained and served and get everybody understanding what's happening, versus using Kubeflow, when you can take Kubeflow, combine with some of these tools, and instead of it taking months, it only takes days to get things up and running and working. So Kubeflow, regardless of where you get your Kubeflow from, whether it's from the strict open source version that you get from the Kubeflow website, or whether it's from a distribution like Arrikto or others, you can see that Kubeflow makes it a little easier to establish your machine learning workflow and hand off that data and those various pieces of this journey between personas. So, you know, the other thing is that, you know, many data scientists, you know, and ML ops, you know, personalities, you know, use multiple of these, and where they're spending most of their time is putting them together. And again, we as the Arrikto distribution and as the Kubeflow project want to make it so easy so that you're not spending all your time putting things together, but you're spending your time actually gaining the insights that you need. So these are some links to what we kind of call public enemy number one. So the links will be available in the slide deck. But you know, the majority of data science projects don't make it to production. AI is only profitable 60% of the time. Launching these pilot efforts like is easy, but deploying them into production, there's a lot of challenges. And then there's other statistics that show 90% of the models don't make it to production, and 87% of the projects don't make it to production. So with all of that, you know, in mind, you can see that, again, the distributions that are building on top of Kubeflow really want to fix these issues, really want to help folks, you know, make their models and their projects successful and get them to production and gain those insights quicker and easier. So this is where we come in. So DevOps, as most people probably knows, is a subset of machine learning operations. And in order to do ML ops, you need to know DevOps. However, there's so much more that goes into that ML ops than what most people probably realize. So when we think about all of these things, let's talk about what we mean by a platform. So I don't want to read the slide to you, but you know, to get the outcomes that we want, the platform must focus on improving the developer experience to reduce the learning curve so that, you know, teams have the total quality of ownerships. Audit can have a central location to verify those happenings. And instead of requiring audits of every pipeline, use the platform in an opinionated way to encourage broad improvements. But we only have to do it in ways that make the right thing the easy thing to do. So when you're thinking about what a platform is, again, we want to make the right thing the easy thing to do. And making the right thing easy and the behaviors that we want to improve are harder, right? It's not impossible, but it's kind of harder when you're thinking about the platform as a whole. And so what we mean by that is we want to have a platform that enables organizations to migrate to better platforms without removing the ability of the older development efforts from using the platform at all. So, you know, the platform that we're going to talk about here in a minute, you know, is that system that allows the product teams to focus on what they're really delivering and how to improve that quality without having to build basic infrastructure and worried about all those changes. So as I mentioned before, you know, this is Kubeflow. We saw that in the first slide. And as you can see, Kubeflow is actually a platform. It's not just this community or just this tool. It's a complete platform. And you can see the platform is indicated in the dark blue. And we are at Arrikto, and what other distributions are doing is to increase the flexibility, the customization, and the extensibility and integration of other applications and tools, as you can see, but not limited to what's in the lighter blue areas. So how do we do that? You know, we at Arrikto are more than just a platform. You know, and this means that, you know, the things that are we probably look at this slide and thinking, okay, this is Captain Obvious here, but Kubernetes is still hard, and we want to relieve that pressure. We take care and have ways to run Kubernetes as well as the machine learning and the artificial intelligence platform on-prem or in the cloud with varying amounts of ownership. And I'll talk about what I mean by those varying amounts in just a moment. Kubernetes is our engine, and we are using it for its raw power and potential, because Kubernetes does have a lot of potential and a lot of power for its use, especially, when you think about the users who've been using it since day one and the things that they're able to do with just Kubernetes. And then you layer Kubeflow and our distribution on top of it. So then you get even more extensibility and customization around how you're using Kubeflow, or how you're using Kubernetes. And we aren't forcing the end user to define how their services run or where they should live. We're just making it easy for them. We want to handle the storage, the networking, and all the other hard stuff that goes into it. And what I mean by varying amounts of ownership is that we have on-prem self-hosted, we have on-prem managed, we have as a service, we have cloud hosted or cloud managed. It's still all the same to us because we see this as your Kubeflow environment. It's your environment mesh. We don't see it as a cluster or as a hard boundary, although it could be, but we don't see it that way. And it shouldn't matter where it is on how you manage it. We're just going to help you. We can orchestrate and move artifacts seamlessly with GitOps configurations on our rock volumes. This needs to work for all sorts of customer models, and it feels like sometimes that we're hunting unicorns when we really need to be creating unicorns from horses, right? And taking an org that is like low value and common, but in some cases can pull the cart, right? We want to take it to the next level and make it seem like it's just magic behind the scenes, because that's what we need to provide. We feel like we at Arrikto need to provide the magic. And we do this by fostering an ecosystem with partners and projects. So that ecosystem is not just the ecosystem around Kubeflow, but it's also adjacent partners and projects that are close to and run with and can be modularized with Kubeflow. So imagine things like Min.io or Arise or others that are out there that we can figure out how to work with. And if you want us to incorporate those, we want to do that too. So we are looking very hard at partnering with those in, near, and around the Kubernetes and Kubeflow ecosystem. So a little bit more about what you see and what I just described. We have Kubeflow as a service, and it's single node, and we launched that a few months ago, and you can go to Arrikto.com and you can try out. It's an easy way to try out Kubeflow, because Kubeflow is a little complicated. So if you want to have a demo of it and try it out and deploy a notebook, you can do that free with our Kubeflow as a service. And we also have our Arrikto managed Kubeflow, which is our on-prem or our cloud hosted piece of it. And that that can either be on-prem or run in the customers or Arrikto's tenancy. And this is managed by Kubeflow. We have our on-prem offering, which is on the customer's bare metal and self-managed. We'll offer support. And then we have Arrikto Kubeflow, which is cloud hosted on the customer's tenancy, and they manage it. So at the base of every one of these is our Arrikto Enterprise Kubeflow. And as you can see, that's our end-to-end machine learning platform. So that's what we offer, and that's our products that are based on top of Kubeflow. And while we're super excited about making it easy or easier for not only the machine learning engineer to be able to help the data scientists gain their insights, but also to help the data scientists also understand all the capabilities that they have with Kubeflow, and by using a distro that's built on top of Kubeflow. And with that, I will, if you want to know more, you can, if you're interested in Kubeflow, you can check it out at kubeflow.org. If you want to know how to get involved in the Kubeflow community, or you're a distribution and you're not listed on the Kubeflow website and you want to be, check out the docs. Or if you can't figure out where you want to get involved or how you want to get involved, send me a message. There is a place for anybody who wants to be involved. You don't have to be a data scientist. You don't have to be a machine learning engineer. There's a place for you in the community. And if you want to be involved in the Kubeflow community, and you can't figure it out, I'll be more than happy to help you. We'll find a place for you to get involved. If you want to know more about Arrikto, you can go to Arrikto.com. And if you want to know more about Arrikto's products and you'd like somebody to contact you from Arrikto, you can go to Arrikto.com/contact and you can find out more. So with that, I'll stop sharing my screen and say thank you so much. And I was trying not to be too chatty. So
Yeah, hey, yeah, Amber, that was great. Real quick, what kind of car do you drive?
I drive a Dodge Challenger. It's a wide body with the Scat Pack. It's the SRT with the shaker. So, and it's a manual transmission. So.
Oh yeah, that's right. It's manual. Okay, cool. And then Jagane, I'm going to ask you guys also what kind of car. I'm going to guess. Do you have a family, Jagane?
I do have a family. My son is grown up, and they're empty nesters. So.
I say you're a Lexus RX 350.
I have a couple of cars. I have a 11-year-old Lexus, and I have a 911 turbo stick shift. So.
Oh yeah, I do too. Yeah, what year is the turbo?
2011. That's the last generation they made with a stick shift. After that, it all became automatics and got faster than I want to deal with. But
I know,
yeah.
I know. Mine's a
I like the stick
2008.
shift.
And stick shift,
Indeed,
yeah.
I can't believe Amber mentioned that as well. It is a pleasure to see that. Anyway, what year is yours, Chris?
2008. Yeah.
So, nice.
And I always want to sell it, but every time I have to take it in the shop and it's $2,500. I want to sell it.
That's the price to pay. All right, folks. Thank you for attending our webinar, Managed Multi-Cloud SaaS MLflow. My name is Jagane Sundar, and I have our co-founder, Jitendra Pandey. And as we mentioned earlier, we have a background in Hadoop, HDFS, and various other distributed computing systems. And then we got on AWS. We just love the architecture. So we built a version of MLflow that is enterprise-wide, available as a service, and is keen on things like sharing, authentication, authorization. So today's agenda, we'll talk about the architecture of our MLflow service. We'll see what it takes to sign up on the marketplace and buy it. There's a reason why I want to show that. And then we want to talk about Concurrent for MLflow, which is a project we've created to run MLflow projects in Kubernetes. And we're trying to bridge between MLflow and Kubeflow. And we'll talk about that in a little bit more detail. Jitendra will show you a demo of that. So MLflow, we think, is the industry's top experiment tracking and model management tool. It seems to be very well accepted in those particular areas of functionality. We are standing on the giants of shoulders. It was originally created by Databricks. A lot of folks have adopted it, and we have taken the open source version and added some enterprise capabilities to it. It's well awarded, and I don't want to go too much into the details of MLflow. We do have some slides to show you capabilities of MLflow, which we can get into if we have a time. So what are the enhancements that InfinStor makes to open source MLflow, and what did we do to turn it into an enterprise-wide service? It falls into three broad categories. On the security side, we have authentication. You must log into the service to use it. Authorization. By that, I mean experiments and models can be authorized as RBAC, basically reader role, editor role, manager role. This we think is essential for sharing these capabilities in regulatory compliance scenarios, in intellectual property protection type of scenarios. We have that built into the core of the system. Finally, we also have the ability to manage access control to your artifacts. One of the things about MLflow that's a little bit frustrating is that it doesn't really do anything for artifact access control. If you want to store your artifacts in S3, you have to distribute S3 access keys and secret access keys along with your MLflow credentials in order to access that. That is too cumbersome and very complicated for enterprises to deal with. So in our system, you log in using your corporate authentication credentials, And if you have access to a particular experiment, you also have access to the artifacts for that experiment. If you have access that allows you to read and write to it, you can read and write to it. Otherwise, you can just read to it. Integrating that access control makes the system much more manageable from manageability perspective. We focused on availability of our system. Our system is built such that it is available 24/7 in the same region. If the whole region were to go down, you can bring up the service in a backup region in about 20 minutes or so. High availability within the region is automatic. Administrators do not need to do anything to get that capability, but across regions is a manual operation that takes about 20 to 30 minutes. We'll talk about the architecture of our system in the next few slides, and there you'll understand what I mean by that. Finally, the third area where we've made improvements to open source MLflow is this project called Concurrent for MLflow. What we do is we define ML projects, define a DAG using ML projects, and we have the ability to run in parallel complex pipelines of or DAGs. So you can do things like pre-processing images from DICOM to NIFTY format. You can do that in parallel. Then convert those NIFTY forms into run a model on it to determine whether there is a blockage in the artery or whatnot. And finally, you can do some reporting or things like that. This would be a 3-node DAG which you can run in parallel. So if you have a lot of images coming in and you want to do this without having to handcraft your own parallel processing system, you can use Concurrent for MLflow to do that. Jitendra will demonstrate this in the second half of this presentation. So the architecture is very interesting. We chose to use DynamoDB as our persistent store for MLflow, and we use AWS Lambdas as our compute capability. The end result is that we get phenomenal scalability and you get to pay exactly what you use. The second aspect of our architecture that I want to highlight here is that the Lambdas and the Lambdas run in our AWS account, whereas you, the customer, have the DynamoDB database, which holds the MLflow metadata, and the S3 bucket that holds the MLflow artifacts. Those belong to your account. Now, this architecture makes for a very interesting pricing model. We are able to offer you at $120 a year per data scientist. We can offer you unlimited experiments and models. Compare this with companies like Weights and Biases, where their service includes things like you are allowed 250 hours of uptime. How does one even measure that? It makes for a very hard to use service, and it's hard to define that as a service. Ours is truly software as a service. You purchase it $120 a year. You set up your own bucket, and I'll show you how that works. Your own bucket and DynamoDB database, and you pay for exactly what you use. If you have one data scientist using it, it's a small amount of money, a couple of bucks a month. If you have a few hundred jobs and data scientists using it, maybe it turns out to be $100 or $200 a month. That's the beauty of the cloud, and we've highlighted that. Again, I want to highlight that we are compatible with SageMaker, both on the Studio Notebook side and on the model deployment side. We are truly a service MLflow that works well with all the tools in this particular diagram. So with this, let me kick off a short video showing you what it takes to sign up for our service. You go to the marketplace, search for MLflow, choose InfinStor MLflow, and you click on try for free, for example. And once you do this, you will be taken to the contracts page. You click on create contract, and you have once you accept the contract, you'll be redirected to our service website, where you will create an account for yourself and set it up. I'll show you how the setup starts and then hand it off to Jitendra, and we'll talk about Concurrent for MLflow. Here, I do not have an account, so I'm going to click on sign up and create a username and password. There's a reason why I want to show this. one of the things about the way our service is architected is that the DynamoDB database and the S3 bucket reside in your AWS account. You might think that that's a lot of setup, but it's not. We provide you with a CloudFormation template that is very easy to use, and I want to just show you how easy that is. I'm logging in as the newly created administrator account into the InfinStor service. And once I do that, I will have the ability to kick off the CloudFormation template. This is our dashboard. This is not the MLflow UI. The MLflow UI is available at a different URL, and it's the standard MLflow user interface with some enhancements for concurrent. So here I'm going to click on start the CFD. It's going to show me a warning saying it's going to create a DynamoDB table and an S3 bucket and the role. I click on OK. It's now going to redirect me to the AWS CloudFormation template console. And once I click OK on this, and that's what it takes to set up your account for use with InfinStor service. Now, once you have this account set up, you can create data scientist users, and they all will be able to authorize and share experiments and models with each other. Now, let me start up the concurrent for AI demo. Jitendra will talk to that, and go ahead, Jitendra.
Yeah. Hi, everyone. So this is our concurrent UI integrated with MLflow. So we start with creating concurrent, which is a graph of processing. We will schedule it across 2 different regions in AWS. So first stage of processing will be an EKS cluster in US West 2. And the second stage will be in EKS cluster in US East 2. So we have a pre-configured Kubernetes cluster. We have CloudFormation templates to configure your cluster as well. And your ML project resides in a GitHub repository. You just specify the path, and your first stage is configured. Second stage is a similar configuration. One important thing to note here is the maximum data partitions, which is used for parallelizing your processing node. So if you have specified, say, 3 partitions, we will create 3 containers. We will partition the data automatically and schedule it in those many ways. So we are specifying the input. Here we choose a directory partitioner. You can specify a custom partitioner where you can specify a Lambda function, which will look at your metadata and do the partitioning. We have an API for that, and specify the bucket name and the path in the bucket for input data. And as soon as these things are done, we will be ready to launch. So we are connecting the 2 nodes. The first stage is a pre-processing step. Second stage is a classification step where we apply a classification model to do the processing. So this model is also residing on the S3 bucket. Model is not partitioned. It is available in all the containers. And we will show that concurrent is inherently integrated with MLflow, and all the processing that happens here gets reflected in the MLflow console as well. So now we are running the template, which is my graph. And once it is launched, the parallelization will kick in automatically. It is the data-aware partitioning. So the partitioning happens at runtime. So first stage, see, now got split 3 ways because we specify data partitions as 3. And now we see that there is a new experiment created for this particular DAG. And in this experiment, there are 3 runs which have been launched, which are correspond to each of the containers. And we can go to the Kubernetes CLI also to look at the, so first we pick the cluster in US West 2, which was the first stage of processing, and look at the pods. So we can see here that, okay, the initialization pod is launched already, which will do all the setup for launching the tasks. And we can follow the graphs here. These graphs will be uploaded to the MLflow artifacts as well. So these logs will always be available if you want to come back and look at it in future for debugging or for any other compliance purpose. This all data will be available in MLflow. So the 3 tasks are running, which correspond to those 3 containers. And we can go to the parent run and again look at the graph. And okay, so the first stage is complete. Now the second stage is also split 2 ways, because there the partitioning we had specified was 2 ways. Again, the partitioning is based on data and actual content of the data. It's very dynamic. And the 2 containers corresponding to those are launched in the same parent run. And again, in Kubeflow, we have to switch to the this US East 2 cluster context and look at the pods. So here the namespace was different. So we have Concurrent provides the cluster management capability also. You can bring your own cluster and configure it to be used with Concurrent, which also resides in your account. So second stage, we see 50% is done. One of the nodes is done. So next one should also be done shortly. All right, so now all the processing is complete. This should reflect in the MLflow UI. So we see that the parent run is complete and all the 5 tasks of the run are complete. And now we can go to any of those runs and look at the output is captured over here. And the logs are also uploaded in here. Any metadata associated that you want to log in. This metadata is very important because any subsequent processing you want to do, this metadata can be used to partition the data. So that was a quick demo in the short time, whatever we could cover.
Yep, thank you for that demo, Jitendra. So as you can see, we have taken the concept of MLflow project and we've built complex DAGs, and we have run the DAG in a parallelized fashion across different Kubernetes clusters in 2 different regions. Questions, we can answer those. I think we are at 9:40, so in the interest of time, we will hand it back to Chris. And thanks for having us, Chris. Thanks for attending, folks.
Yeah, I have to swing by your place and try out that turbo. Yeah, we could swap turbos for a day. We live near each other too. Yeah.
Would love to do that, yeah.
One really quick question. So is concurrent, it's basically, I guess, a competitor to Kubeflow pipelines, or does it work?
It is, so we are working towards taking the Kubeflow pipeline DSL as is and running it in our environment. Our focus has been on data partitioning, parallelization, and multi-cluster, multi-region multi-cluster. Kubeflow pipeline today operates in a single cluster, and it appears to be fairly focused on a single pipeline of work, while we are more focused on a DAG and parallelized, run across different Kubernetes clusters on-prem and in the cloud across different regions. We think that the cost factor in compute is so high compared to data transfer charges that all sorts of new architectures where you do different processing in different parts of the world are reasonable and actually expected given the cost. Like, for example, AP South 1, which is Mumbai, doesn't have the latest generation of NVIDIA GPUs. We have customers who do that portion of their DAG in US East 2 and the rest of it in back close to the data in AP South 1. Those sort of problem solving capabilities are important for AI going forward.
Cool. Awesome. Okay, and I do think we're out of time, so questions in the chat if anyone has them, and I posted links. Okay, who's up next? Joel, can you introduce yourself and hop on video if you'd like, at least share your screen?
Yes, perfect. Yeah, share my screen.
And yeah, I have to say, I tracked Joel down. I saw one of his talks internally and was so excited. I tracked him down right afterward and said, please speak publicly. So this is the public version, which I don't think is that much different, right?
Yeah, I have updated a bit, but yeah. Hi everyone, I'm Joël Farvault, based in Paris. So yes, you can notice with my big French accent, but that's okay. So happy to be with you today and to share how to build a modern data mesh serverless architecture. The approach will be first to present very quickly few concepts about data mesh and to present the enablers to build a data mesh architecture. For this session, I will focus on two enablers and I will demo two enablers, but I will present also, I will share with you other options. So that's maybe an opportunity to come back again and to present other alternatives, other solutions to build a data mesh architecture. So let's start by, maybe that's better. Let's start by, I hope that in my screen you don't see again. I think like that is better. Yes. So let's start first by presenting why we are talking about data mesh. What are the main challenges that our customers are facing about data management? We can highlight 4 types of challenges. The first one is around access to the data, and especially the fact that many customers, they have already built a data lake, and they have a global data lake, a central data lake, but they are facing some challenges to get all the flexibility that they would like from their data lake. And on the other way around, on the other hand, you have customers that they have several data lakes, but those data lakes become data silo. So the approach is how we can break those data silo and get access to the data that can be easy to consume. Or even how your data lake can be also as flexible as your business would like to get all the data that they want. So there is the first point about getting access to the data. The second type of challenge is around data governance. And usually with data governance, you have always a kind of central data governance team that define the rules on how to access the data. And it can be a kind of bottleneck in how you can leverage your data and get access to the data. So that's the point of to move from this central data governance toward a federated data governance, which still some audit and controls, but a data governance that is close to your business, and to break the approach of a central data team toward more federated and also to give ownership to the data close to your business. Another type of challenge is around data architecture, and especially on data architecture, how you can build an architecture that is more agile with the concept of producer and consumer, and even to have a decentralized architecture close to your business topics. And the last point is, I would say the most important one for the business, is how you can also change the approach or shift toward always speaking about your data platform infrastructure and not consider that as only a technical stuff, but more to consider your data as a product and make your data an opportunity to align and to even bring new business opportunities. So if you sum up with these 4 topics, consider the data as a product, make easier to access your data and to break the data silo, to get a federated data governance, and to have also a decentralization or to organize your data around business domain, that's exactly what we name data mesh. So data mesh is based on these 4 principles: domain ownership, to structure your data around business domain, to consider your data and to see your data not only as an asset, but as a product that bring value to your business, to also promote a self-serve data platform, which make easier for anyone in your company, and you don't need to be a data engineer to get access and to use your data platform, and to have a federated data governance, so a data governance that is close to your business. So that's the principle. And if you want more information, you have the great book from Zhamak Dehghani that explain in the detail how all the concept about data mesh, what does it mean, what are also the architecture pattern around data mesh. But let's consider for today more precisely on AWS, what does it mean? First point, maybe because we speak a lot about data products, and I wanted just also to clarify what is a shift toward a data product approach, because that is always a question that come, yes, data product, but concretely, what is a data product? Data product means that you move from a traditional approach of you pull your data from your data source, and in the traditional model or the usual model, that's the responsibility of your consumer to have all the heavy lifting, which means to extract the data, transform the data, load the data into their system. So the responsibility is on the shoulder of your consumer traditionally. When you are into this data product mindset, you shift that approach toward the producer is the one exposing the data, is the product that you want to expose. So meaning that the cleansing, the preparation of the data is on the producer side. And you make the life of your consumer easier by exposing the data that your consumer expect to make to simplify and make easier the consumption of your data. So in the data product mindset, it implies that you put your customer first in what you expose to your consumers. So you define clear contract, you define a clear documentation, and you make easier the consumption of your data. That's, I would say, one of the key approach for a data product mindset. And when you go deep in more detail in also setting up a data mesh architecture, it implies also to consider different type of topologies. You don't have one a standard or a one-way approach to build a data mesh architecture. You have several models that you can consider in your data architecture. First, you can start by the traditional central hub and spoke model. So this one, you have one producer and several consumers, and all the consumer rely on the unique producer of your data. So that's I would say the model with a central data platform. But when after you move to a data mesh or this producer-consumer model, you have two types of topology. One is the peer-to-peer model, which means that the producer interacts directly with the consumer, and there is the negotiation of the service level agreement that is done between the producer and the consumer. And that's the responsibility of the producer to manage the relationship with the consumer. And by the way, as you can notice in this slide, you can use one of our service, leg formation, to implement such architecture. And through leg formation, you can definitely, I will show you just after, you can definitely set up such architecture by sharing your data between your consumer and the producer. Another type of topology is the data mesh one. In the data mesh topology, you have producer and consumer, but you have this central layer, a central leg formation layer, and this central layer enable to have this audit and control of what can be shared between your producer and your consumer. You define type of rule of the game of what you want to share with your consumer. So that's different type of topology. There is no good or bad topology. It depends really on your business context. For instance, when you consider a regulated business, regulated market, they are more keen to consider the data mesh with a central layer rather than other type of market. They are more keen to have this peer-to-peer model. Now, moving to the enablers and how you can build such architecture. You have several options, and even this slide shows only a partial view of the option for building an architecture. First of all, it depends the type of data platform that you use. If your data platform is mainly based on data lake, which means S3 bucket. If it is mainly based on S3 bucket, you can build your architecture using leg formation, and even you have some accelerator such as datamesh-utils that enable to quickly set up a leg formation based architecture. You can also use an open source solution, data.all, which enable you to build a data marketplace. If your architecture is mainly based on data warehouse and especially on Redshift, you can also build your data mesh architecture using Redshift data sharing. There is also other options on that regard. You have also the open source solution Data Hub that can be another alternative to build this type of data mesh architecture. For the session of today, I will present the first two options with leg formation and data.all. I will show you some demo, and the scenario is, I would say, very simple. You are part of a corporate company with several entities. You are a data engineer, and you would like to access a data set. So let's present the first one with leg formation. Before just moving to the demo, to bring some explanation about how leg formation work. So leg formation is a native service that enabled to define a permission model on the type of data that you would like to expose with your consumer, and the rationale of how the data share works is based on sharing the data catalog. So instead of duplicating the data between your producer and your consumer, the data remains still where they are stored, where they are located in the producer account. And by the way, you can notice that this architecture is based on the multi-account architecture with a producer account, a federated governance account, and a consumer account. The data are stored in your producer account, and you can access the data through the catalog, and it's only the catalog that is shared between the producer, the governance account, and the consumer. Let's move to the demo to understand a bit how it works using leg formation. So, okay, let's move into one example. So we are here you are here, so in the producer account. So let's imagine that you want to share this data set. The data set that you want to share between your producer and your consumer account contains some customer information, and that's this data set with this customer data that you would like to share with your consumer. You can notice that some information has been anonymized, and you have a mix of data that contain generic information, and also some more sensitive data. So that's is on the producer account what you would like to expose. To expose your data, you use leg formation. Sorry, I just need to, there is a timeout, excuse me. So you are connected so that's the point. That's okay. So you are connected now in the central account. I have shared the data catalog. The data catalog has been shared. So basically, when I say I share the data catalog, is between the producer and my central account, I have shared the description, my glue data catalog, with the list of metadata that has been shared. And you can notice that here this glue data catalog has been only shared. Why is important is that the permission and the access to your data stored in your producer account is done through the data catalog. And by the way, from the central account, you are able also to define some filters in leg formation, and you can also define what type of columns that you would like to exclude or to include. You can choose you would like to include or to exclude from your data set. Even you can define some raw filter expression in leg formation, which means that even you can define some conditions and saying, yes, I want only to share data from only this column and only this subset of data. So that is what you can do from the central account. And now, when I connect in my consumer account, I'm a business analyst here. I want to get access to the data. I use leg formation to get access this data set. And you can notice here that as a business analyst, I access exactly the same data set that is stored in my producer account, but only I get access to a subset of data that has been shared with me, and I can make my query in Athena, and I have access exactly to the same data, but only a subset of these data that has been shared by the producer account. So now, moving to this first approach to build my architecture, yes, I have shared my my data catalog. As a consumer, I can access to my data set with some rules. The point is that this architecture has been fully built using this library that is based on Python and Boto 3, on which enable me to easily build this architecture in less than 5 minutes. So by providing setting up my leg formation, to manage also the fact that I share my glue catalog and I use resource access manager to share my catalog from the producer to the central account or the central account to the consumer. By the way, I can use exactly this architecture to build also a peer-to-peer approach, which means that you don't have to go through a central account. Directly, you can share your catalog between your producer and the consumer accounts. So that's one option. And by the way, using this approach, which is native to AWS, you can build a foundational data sharing architecture. You can set up easily a data mesh architecture using a lake formation. Even though you don't have a proper user interface for the approval request, and as you can notice in this model, we use only the technical data catalog as a way to explore your data. So that's a first approach. Now, another model to build that architecture is using this open source solution, data.all. So data.all, the approach is to provide a marketplace, which means that it's easy for the producer to expose their data, to share their data. For the consumer, they have a way to easily discover the data. And through this marketplace, you can define also some controls and it simplifies the onboarding of your consumer. From data.all, the point is instead of being in the AWS console, you have a proper portal. And through this portal, you are able to manage all those features, sharing a data set, managing a data set, explore a data set, even you can play with your data. Let's move directly to the solution and see how we can use data.all. So data.all, so first of all, when you connect into data.all, you are in this portal. You use this portal. So it means that anyone in your company can get access to this portal. And first, you can explore your data set by using here first free text search. So you can search on your data set, but what is interesting is to use here those parameters to search in your data set. So first, you can have the possibility to search using a business glossary, and that is a very interesting topic, a very interesting feature, because you can search your sales data. So I'm still a data engineer, and you can use business business concept to search your data. So you don't need to use the table name or the column name. So for instance, here I say, I want to search my sales data that contains the wholesale price, or even you can search in your customer data. You would like to get customer data that contain education status, because there is the possibility in data.all to build business glossaries. And if I take the case of customer, I can define glossaries with business concept, and I can map the business concept with my Glue data catalog, which is very interesting because remember, with lake formation, we were only able to search using a technical metadata. In the case of data.all, we are able to map a technical metadata with a business data catalog. You have also other options. You can use the classification level, the region, a topic, that's more a business domain. You can use also tags, like tags at the console. You can also search your data if it is a dashboard, a table, a data set. So you have these, all those options to search and to explore your data set. So there is a proper capability for data exploration. So now let's continue in our example. I want to get access to the sales data and I want to access it. And I receive here the message that I'm not authorized to access the sales data, because there is the possibility in data.all to request the access to the data, or even you can here also access here, you can see here that there is the possibility to request or to submit a request to access a data set. And you have a proper workflow process that is included into data.all. Now, once I have requested the access, I can now change persona and I can move to the data administrator. The data.all administrator can either approve or reject the access to the dataset. That's, I would say, cover a first part about data exploration, but after your question could be, yes, what is the link between data.all and data mesh? Basically, the link is that all the data that has been exposed by different accounts, by environment. So the data are published through environment, and those environments correspond to a different accounts. So we are exactly in the same architecture as the previous type, as the previous one, with producer, data producer that can expose data set. And if I go a bit into the detail, I can notice that a producer can expose different data set. And if even I go into more detail about this data set, I can either expose unstructured data or structured data that are exposed as a data product. And once I have access to my data product, I can after play with my data. So I can, first of all, I can go to here to worksheet, and I can access to the data set that I got the approval. So here the customer, and I can, from the portal, I can create any Athena query from the portal. I can even, and that's make the link between getting access to the data and also the possibility to spin up a notebook or even SageMaker Studio, or even what I can do is from the platform, I can also use my data set into QuickSight. So there is the possibility to explore the data, request the access to the data, and after play with my data set once I got the approval. Could be to use it into my notebook or to use it into QuickSight for the dashboard. So now we have presented two options to build your data mesh architecture. You can use data.all as a data marketplace. It's easier to publish the data, to explore the data. You can use also business data glossaries, link with machine learning, data viz, data preparation, and that's definitely a very powerful accelerator for building your data mesh. But if your architecture is based more on data warehouse, you have also the option to use Redshift data sharing. That's also another interesting feature which enable you to use the data from one cluster and to expose your data to another cluster, to a consumer cluster, using the Redshift managed storage, and from the Redshift data sharing, the consumer cluster can get access to the data exposed by your producer. And after, you can create some specific views on the data that has been shared in order to apply the permission from at the consumer level. So permission such as exactly the same permission that we have implemented with lake formation. So that's another possibility to build also your data mesh architecture. For the sake of the time, I won't be able to make the demo for this one, but that's also a third possibility to build your architecture, and it's another way to build your foundational data sharing architecture using Redshift. Thank you for your time, and sorry if I took a little bit more time.
Thanks so much, Joel. Yeah, no, it's a great talk and demo here. Very excited. We did have a question here, maybe just quickly, thinking about this data mesh concept, the approach, does it support having different contracts per consumer?
In the case of leg formation, I would say that you would be limited on the case of leg formation will be one contract, but the same contract because it's the sorry, excuse me. There is two options. The glue data catalog that you expose is the same. So yes, it will be one contract that you expose for several consumers. You can after use data filters that it's a possibility for one consumer or other consumer to adapt what you want to expose. So it will be the same glue data catalog, but using the data filter, you have the possibility to adjust. In the case of data.all, will be the same contract for all your consumers. And the case of Redshift data sharing, I would say that is using views that you are able to change a bit your contract.
Cool. All right, thank you. Yeah, any questions from you, Chris?
No, I think we're good. Thank you to all the speakers and the startups as well. And yeah, Joel, thanks for staying up a little later. Probably dinner time by you. So appreciate it. Antje, are we doing, we have to figure out if we're going to do next month, right? Because I think it falls during the week of Christmas.
Yes. So the December meetup, we might move to January because I guess everyone is kind of busy and has plans for the holidays in the week of Christmas. So yeah, keep an eye on the meetup site. We might move that to January.
But the next topic will be, what's the next, if it's December or January?
Yes, we're having another guest speaker, Adi Pollack, and talking about Git for Data with LakeFS. And then we'll probably do a recap. So we have AWS reInvent coming up next week, our annual big developer conference. So we'll do a recap of all the big announcements that will happen in our next meetup after reInvent.
I forgot about that. Yeah. Wow. Is reInvent already next week? That's crazy.
I think it is. Yes.
Registration link.
Time is flying.
And time is flying. Yeah. We will post the video for this as soon as Zoom encodes it and lets me download. And we'll post to the YouTube channel, which is YouTube Data Science on AWS.com. And thanks again to all the speakers. Thanks, everyone. And have a great week and happy Thanksgiving.
Thanks, everyone. Bye-bye.
Thank you.
Thank you.
Thank you.